to find the polynomials when the sum of zeros that or roots alpha plus beta and product alpha beta of zeros are given. So whenever the roots, one root is alpha, the other is beta, if their sum is given and their product is given, how we will find out the actual polynomial. Suppose given that alpha plus beta is equal to minus 3, one example, and alpha beta is equal to alpha into beta is equal to 2. So what should be the polynomial when the root sum is minus 3 and their product is 2? We want to form a polynomial. So we know that alpha plus beta is equal to minus b by a in the standard form of ax square plus bx plus c is equal to 0. In this case, alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a, that is equal to minus 3, that is equal to 2. We can express it. Minus 3 is minus 3 by 1. Why we root 1? Because a is same. We want to transfer into such a number that in both the cases it will be same. So minus 3 means minus 3 by 1, 2 means 2 by 1. So without any prejudice or without any wrong or without any hesitation, if you take a to be 1, no problem will be there. If we take a is equal to 1, then b is equal to 3 because minus b is there. So b is equal to 3, minus b by 3 is equal to minus 3 and c will be 2. So alpha plus beta is equal to minus 3 and alpha is equal to 2. It is okay. So from alpha and beta we transfer to a and b. From alpha given alpha plus beta and alpha beta, we find out a, b, c. Wait, this then a is this, b is 3, c is 2. Now we can form easily the polynomial is ax square plus bx plus c, where a is equal to 1, b is equal to 3, c is equal to t, c is equal to 2. So the actual polynomial is x square plus 3x plus 2. Or another process. So another process is somehow it is lengthy. You leave this, you come to this. In factorization, every times we know that multiplication first number, second number is equal to a c, and first number, second number, that is equal to alpha beta minus b by a, that is equal to alpha beta, it is called alpha plus beta. In factorization process, we apply this process. We should add two numbers, that will be alpha beta, and you will multiply this alpha beta. You use that process here. So the required equation will be written here. X square minus x plus alpha beta into x plus alpha into beta. You see that it is product, it is their sum. Okay, alpha into beta, alpha plus beta minus. Nothing but the factorization method of this. So how you are factorizing this? When you are factorizing x square minus alpha plus beta x plus alpha beta is equal to 0. Where how you are factorizing this? It will automatically x minus alpha, x minus beta. If this will be 0, what will be x? And x is equal to beta. Is not the two roots, x alpha, x beta. So by any process, either you apply this or directly you can write this. If alpha plus beta is given, alpha beta is given, the equation will be x square minus alpha plus beta x plus alpha beta. Now we will discuss about some more questions. So more questions. Find the zeros or roots of the polynomial and verify the relation of zeros with the coefficients. 4u square plus 8u. So this is a polynomial. Every time the polynomial should be equal to 0, then it will be equation. Otherwise, how will you find out the value of the zeros? Zeros means the polynomial value should be 0. After equating 0, you will find out the value of the unknown. Here the unknown is u. For u taken common, u plus 2 is equal to 0. So u, when a into b is equal to 0, what is the criteria? A into b is equal to 0. What does it mean? Either a is equal to 0 or b is equal to 0. Both may be 0, no problem. But individually we should take when if two numbers are multiplied, if one is 0, it is sufficient, the result will be 0. Both need not be 0. If either a is 0 or b is 0. Similarly, if x minus alpha into x minus beta is equal to 0, what does it mean? Either x minus alpha is equal to 0 or x minus beta is equal to 0. The same process is applied here. The same process is applied here. For u, so either for u is equal to 0, this implies u is equal to 0, or u plus 2 is equal to 0 implies u plus u is equal to minus 2. So how many zeros are there? 2 zeros we get. Let alpha is equal to 0 and beta is equal to minus 2. That is the obvious. We have taken that two roots are alpha and beta. If one root is 0, other is minus 2, one is 0, the other is minus 2, then standard formula what is A is equal to 4, B is equal to 8, C is equal to nothing. C is nothing means C is 0, we can take it as 0. Now alpha plus beta, alpha is 0 plus minus 2, that is equal to minus 2, that is minus B by A, minus 8 by 2 is equal to minus 2, it is okay. Alpha into beta is equal to 0 into anything else 0, that is equal to 0 by 4 is 0. So the property holds good. What is the, first you find out alpha beta, that means two roots. Then what is the property? Alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Whether you verify it is okay or not. If there is any mismatch, you should think that the process of finding the roots is wrong. Your process of finding the roots is wrong, because alpha plus beta must be always b by minus b by a. Alpha into beta is equal to c by a. If anywhere it defy or wrong, then in the process there is somewhere there is some mistake. Then again you try yourself. Find the polynomial where the sum and product of roots are at. So what is the process? There are two processes, but the easiest process is always this. X square plus alpha beta x, alpha into beta. Alpha plus beta is equal to root 2, alpha beta is equal to root 3. This. And in the next chapter you can read that, or if 5x plus 3 is equal to 0, is not it true that 10 into 5x plus 3 is equal to 0? 15 into 5x plus 3 is equal to 0. This implies 3 by 4 into 5x plus 3 by 0. Why? Every time whatever you multiply is 0, automatically you divide 10. This time divide 10. 0 by 10 I get 0. 5x plus 3 is equal to 0. If you divide by 15 here, 0 by 15 is 0. So no problem. So in general, if x square plus bx plus c is equal to 0, then k is into ax square plus bx plus c is also equal to 0. If k is a belongs to R, real number. Any real number, if you multiply, then the equation, the value will be 0. The same procedure, because it is not in a exact form written, you try to change it into a smoother one, that is multiply 3x square minus root 2x, only to avoid this fraction. You can write this is also a polynomial, no problem, because c is 1 by 3, b is minus root 2, and a is 1. But if you write this in the form of this, it will sum smoother and it will easier. Okay. Find the value of a and b if the zeros of the quadratic polynomial these are 2 and minus 3. Here the question is something different. How will you work out this? Here alpha and beta is given, zeros are given. If the values of a and b of the polynomial of the, find the values. A and b, we will find the value. Given polynomial is x square a plus 1 x plus b with roots 2 and minus 3. Let alpha and beta be the two roots such that alpha is equal to 2, beta is equal to minus 3. It is given. Alpha is 2, beta is equal to minus 3 is given. Then alpha plus beta is equal to minus b by a, that is equal to minus a plus b, a plus 1 by 1. Why? This is b minus a plus 1 by 1. A is 1 multiplied. Similarly, this implies after simplification we get that a is equal to 0. Again alpha into beta is equal to minus 6, that is equal to c by a. C is here b, a is 1, b by b is equal to minus 6. So we get the values and b. Whatever the unknowns, just the solution of the equations. Okay. E alpha beta the zeros of the polynomial px is equal to x square minus 3x minus 2. Find the polynomials whose zeros are these. Where one polynomial is given, its zeros are given alpha beta, and other it is asked to find out another polynomial whose roots will be this, whose zeros are this and this. Okay. If alpha beta zeros of the polynomial this, find out alpha plus beta minus 3 and alpha beta is equal to minus 2. If the zeros of the new polynomial is, if the zeros of the new polynomial is 2 alpha by beta plus 2 beta by alpha, then the required polynomial is 2 alpha plus beta x then the polynomial whose zeros are this and this and this. Okay. So this is one root, this is another root. So in general, from this point we get the alpha and alpha plus beta and alpha minus beta. Individual roots are not traced out, only their summation and product. What is the summation? Alpha plus beta is equal to 3, alpha into beta is equal to 2. We obtained that. Alpha beta, alpha plus beta. From this we want to this. So what is the roots? If 2 alpha by beta, 2 beta by alpha are the two roots, what will be polynomial? Polynomial is x square minus this plus this into x plus this by this into this. Alpha into beta, alpha plus beta minus x, alpha plus beta x, this process. X square minus alpha plus beta x plus alpha beta. The same thing. It instead of alpha, it is 2 alpha by beta. Instead of beta, it is 2 beta by alpha. The same thing. Just you solve it. Nothing else. But just simplify it. You will get that result. Finally, x square plus 13x plus 4. This is the required equation where the two roots are 2 alpha by beta, 2 beta by alpha. What is the value of beta? We have found out that value of beta is 3. Beta is 3 and alpha plus beta is 3, not beta. Alpha plus beta is equal to 3 and alpha beta is equal to 2 minus 2. From this we derived the polynomial this whose roots are 2 alpha by beta, 2 beta by alpha. Individually it is root is not derived. Their summation, by their summation and multiplication we derived the polynomial. Alpha plus beta is equal to 3, alpha beta is equal to minus 2. Roots will be this and this and this, not plus. The roots will be this and this, implies polynomial is the same thing. plus this x plus product. Then after simplification, with the roots are alpha square, this is the, or by simplification if you will multiply 2, then the result will be 2x square plus 5x minus 4, or half into, you can write also in this way, there is no problem. Okay. You cannot write ax square plus bx is equal to c. You cannot write this k into ax square plus bxc. How? It is not possible. But if ax square plus bx plus c is equal to 0, you can write k into x square plus bx plus c is equal to 0. Because if this is equal to 0, k into 0 is equal to 0 automatically. But nothing is given, it is not equal to 0. This polynomial is equal to, will multiply something with another polynomial. Suppose 2x square plus 3 is equal to 3. It is same as 5 into 2x square plus 3. How it is possible? It is 10x square plus 15. 2x square plus 3 is equal to 10x square plus 15. It is wrong. But if 2x square plus 3 is equal to 0, then this implies 5 into 2x square plus 3 is automatically 0. It is k. Okay. The zeros of the quadratic polynomial x square plus 99s plus 127 are both positive, both negative, one positive, other negative, and both are equal. So in this type of questions, what you will do? You write alpha plus beta is equal to minus b by a. This is minus b by a means 99, and both are alpha beta are negative, or larger is negative and smaller is positive. For c by a is either both positive or both negative. Combining both a and b, we get alpha plus beta, both roots are negative, so second is true. So what is the process? How we can find out? This is b is 99 minus b by a minus 99, it is minus. Okay, it is minus 99. Okay, so both are negative, both alpha and beta are negative. No, the question is x square minus 99, not positive. Acha. Then this will be minus 99, that is equal to 99. So it is positive, 99 is positive. So how will get a positive number? If you add two numbers, alpha plus beta, no, it is something different. Okay, it is plus. Okay, plus, this will be negative. Negative 99. Okay, then alpha plus beta is equal to minus b by a means, this is plus means minus 99. So alpha plus beta is equal to minus 99. What is the possibilities? The sum of two numbers are a negative number. So if both alpha and beta are negative, no problem. If both are negative, their summation is also negative. Other, or alpha plus beta, if alpha is positive, beta is negative, in which case it will be negative. If the negative will be more, that is written here. Larger is negative and smaller is positive. If larger is negative, smaller is positive, after adding you will get a negative number. So there are two possibilities, both are negative or the larger one will be negative. But come to the alpha beta. Here alpha beta is equal to 127, it is positive. Alpha beta is positive. So what is the occasion where alpha beta will be positive? Both positive. Both, no, single alpha into beta will be positive. Either both are negative If both are negative, their product will be positive. If one will be positive, other will be negative, it is not possible. So combining these two, here it is both positive, negative, or if larger one is negative, the smaller one positive. Here both are to be negative. So combining these two, what we will get? Both to be negative. Implies that, so we get alpha beta roots are negative, so often one is correct. So both positive or both negative. Combining both A and B, we get alpha and beta both roots are negative, because it is not certain. Both negative is possible, both positive is not possible. If both positive, will it be negative? No. So combining these two, only this one is correct. So they be both negative, otherwise it will not be possible. Okay. The zeros of the quadratic polynomial x square plus kx plus k is not equal to 0 is cannot be both positive, cannot both negative, always unequal, always equal. Let alpha beta are the two roots, implies alpha plus beta is equal to minus b by a minus k, and alpha beta is equal to k. If alpha and beta are both positive, this implies alpha plus beta is positive and alpha beta is also positive. Okay, if alpha and beta are both negative, this implies alpha plus beta is negative and alpha beta is positive. But arrived alpha plus beta is equal to minus k. One is minus, the other is plus. So what will be the possibilities? Since k is once positive and another time negative, implies alpha plus beta both cannot be positive. So this option 1 is correct. Cannot be both positive. If both will be positive, at that time this is not possible to be happened. If alpha plus beta is both positive, it cannot be, k cannot be negative. So only possibility other can be here, cannot be both negative. Both negative, it is possible. If one is positive, the other is negative, this will be negative, cannot be both negative. If both negative, this will be positive, this may be negative. Always unequal, because k minus k, always equal, not possible. So which one is correct? Cannot both be positive. A positive, if they will be both positive, this will defy. Okay, since k is once positive and another time negative, implies alpha and beta both cannot be positive. So option 1 is correct. Similarly, if alpha plus beta are the zeros of the polynomial x square minus p x plus 1 plus c, such that alpha plus 1 beta plus 1 is equal to 0, then find the value of c. What are the zeros? Alpha, beta. Then what is the process? We know that alpha plus first rearrange to the standard form. It is not in the standard form. Okay, first rearrange to standard form in this form. What will that? X square minus ps plus 1 plus c is equal to 0. X square, p is multiplied. Just you take x square x and it is c. Now c is c minus p, b is minus p. So alpha plus beta is equal to minus b by a, this alpha into beta is equal to this. This implies this alpha plus beta, beta plus 1 implies 0, implies alpha beta, because it is given. If this is equal to 0, given, but we have find out alpha, the product, find out the product, alpha plus beta plus 1 is equal to, put the value of alpha beta is minus c minus p, alpha plus beta is p, alpha plus beta is equal to p, this is alpha plus beta is equal to c minus p, this is 1, so c plus 1 is equal to 0, this implies c is equal to minus 1, the value of c. So it is just one type of equation, simplification of the equation or solution of the equation. We have worked out this. If alpha beta are the zeros of a quadratic equation x square plus bx plus c is equal to 0, find the value of difference of the zeros as the values of alpha minus beta. Only one thing you have to remember here, that in our earlier classes you read that alpha plus beta is given, alpha beta is given. How to find out alpha minus beta. But you know that alpha plus beta square is alpha square plus beta square plus 2 alpha beta. Alpha minus beta square is equal to alpha square plus beta square minus 2 alpha beta. These are same. If from this, if you will minus 4 alpha beta, it will come to that alpha square plus beta square plus 2 alpha beta minus 4 alpha beta. This is alpha plus beta square. This is minus 4 alpha beta. This is equal to alpha square plus beta square minus this is alpha square plus beta square minus 2 alpha beta. So this is nothing but alpha minus beta square. So what is alpha beta? Alpha minus beta becomes root over of alpha plus beta square minus 4 alpha beta. Okay, this is written here. If you write it, alpha plus beta is equal to minus b by a, alpha into beta is equal to c by a. You put these two values here, you will get this. This is equal to plus minus, because if alpha minus beta square is equal to this, alpha minus beta is equal to plus minus root over of this. This is the only form, plus minus. So plus minus is here. This is after simplification, you will get that plus minus b square minus 4ac divided by a. So you find that initially it is not given alpha, not given. Only what is given? Alpha plus beta, alpha into jointly. Their joint summation, their joint product is given. Individual alpha beta is not given. So from this we will get alpha minus beta. Okay. If alpha beta are the zeros of the polynomial 4x plus 3x plus 70, find the value of 1 by alpha plus 1 by beta. You try to 1 by alpha plus 1 by beta, you solve this. It will be what will be? The LCM will be alpha beta, beta plus alpha plus beta by alpha. But alpha plus beta is equal to, from this we will get alpha plus beta is equal to, means minus 3 minus b by a, minus 3 by 4, alpha beta is equal to 7 by 4. You put these values here. Alpha beta is equal to minus 3 by 4, 7 by minus 9. It is sometimes 1 mark or 2 mark questions. It is so easy. What should be added to the polynomial x square minus 5x plus so that 3 will be a 0 of the new polynomial? 3 will be a 0. 3 will be 0 means whenever we will put the value of x is equal to 3, this will be 0. Now put x is equal to 3, it will now that minus 1. It to be a 0, the polynomial to be a 0, x is equal to 3. The polynomial to be 0 means the value should be 0. But what is the value now? The value is now minus 1. But 3 to be a 0 of the px, 1 should be added to. So what you will do? If you will equate minus 1 to 0, what you will to do? You have to add 1 because it is minus 1. The resultant was minus 1. If you will add minus 1 plus 1, it will 0. So what extra thing you have to do? You have to add plus 1. So what will be the thing? X square minus 5x plus 5 plus 1, that is equal to 6. X square minus 5x plus 6 is equal to 0. Earlier we have that it is x is equal to 2 and x is equal to 3. Two values are there. 1, 3 is there. No problem. So 3 is the root of this polynomial or 0 of this polynomial. The number of polynomials having 5 and minus 3 as zeros are infinite. The number of polynomials having 5 and minus 3 as zeros are infinite. Generally we know that from 1 it is alpha. Suppose it is alpha, it is beta. No, alpha, beta. Okay, it is alpha, it is beta. Then we can find this for alpha plus beta, x square minus alpha plus beta, x plus alpha into beta. We can find out the polynomial. But one thing is that a polynomial having 5 and minus 3 roots must be of the form x square minus 5 minus 3 alpha plus beta, minus alpha into beta is minus 3 into minus 3 is minus 15. But if we multiply it by k belongs to R, then the polynomial also satisfies the roots. When this will equate to 0, we can multiply any k, that will be the different polynomials where these will be the roots. Only in case of roots it will be equal. Otherwise k we cannot multiply k. Just I have told you earlier. In this case it is not true, but when there is a roots it will be true. So how many are infinite? Yes, there are infinite. Okay, also satisfies. So there are infinite solutions. We can infinite polynomials which will satisfy these two roots. Okay. If the zeros of the polynomial x square plus 9x square plus 13x plus 6a is reciprocal to each other, find the value of a. What is the reciprocal? A reciprocal 1 by a, provided a is not equal to 0. Okay. 0 has no reciprocal, but 5 has a reciprocal 1 by 5, because a into 1 by a is equal to 1. That is the process of reciprocal. But if a is equal to 0, 0 into 1 by 0 is not equal to it. We cannot say in this way it is equal to 0. It is wrong. Division by 0 is meaningless. Okay. Roots are reciprocal means if one is alpha, the other will be 1 by alpha, and alpha beta is equal to alpha into 1 by alpha is equal to 1. Then what is the process? Alpha beta is equal to c by a. C is here 6, a is a square plus 9, 1. This implies this is equal to 0, this implies this, a is equal to 3. We will find out the value of a, directly we get the value of a. If the zeros of the quadratic polynomial ax square plus b is equal to 0, where c is not equal to 0 are equal, then show that c and a have same sign. Where c is not equal to 0, c is not equal to 0, then show that c and a have the same sign. Since roots are same sign, quadratic polynomial where are equal, then show that c and a have, since roots are same given, roots are same, but not the sign is given. What is positive, negative is not given, but they are same. If 2, it is 2, 2 and 2. If it is minus 3, it is minus 3 and minus 3. So alpha is equal to beta and alpha beta is equal to alpha into alpha. This implies alpha square is equal to c by a, but alpha square is always positive. Alpha square is always positive. Square of any number is always positive. So c by a must also be positive. So c and a, suppose a by b is positive. What are the alternative? If it is positive, it will also be positive. If it is negative, it is also negative. So simultaneously they will be both must be same sign. Whatever a and c, they will be of same sign. If minus, it is minus. If plus, it is plus. Okay. Otherwise, a by b will be negative, or c by a, it is c by a. C must have the same sign because it is positive. If c by a is positive, both should be either positive or negative, but c by a is negative. They cannot be the same sign. There must be alternate sign. If one is positive, other is negative, or if one is negative, other is positive. So in the next class I will finish with some other questions. For this time let us stop this chapter. Okay.